Today, we're going on a bit of a journey. We're going to try and understand the true scale of the universe, but not by measuring how far apart things are, but by looking at their volume. How much stuff you can literally fit inside other stuff. We're going to start small with things we all know and end up somewhere pretty mind-bending.
So let's just get right to it. The big question: what is the single biggest thing out there in the universe? It sounds like a simple question, right? But the answer is way more complicated than you'd think. To even get close to an answer, we've got to build our sense of scale from the ground up.
And I promise you, we will get there. But before we launch ourselves into deep space, we need a baseline, a starting point. So let's begin with something we can actually wrap our heads around, right here on planet Earth.
Okay, first things first. Let's talk about our main tool for this trip, volume. Our basic building block is going to be the cubic meter. So just picture a box, 1 meter long, 1 meter wide, and 1 meter tall. That simple box can hold 1,000 liters of water, and it's the yardstick we're going to use for everything that follows.
All right, our first stop is home. We're going to start by measuring our own world, from some of the biggest things people have ever built, all the way up to the incredible scale of nature itself.
Let's start with a classic man-made wonder, the Great Pyramid of Giza. It has a volume of about 2.6 million cubic meters. Pretty impressive. But NASA's Vehicle Assembly Building, where they build the giant rockets, it could swallow the pyramid 1.5 times over. And what about all of us? All 8 billion humans on Earth. If you combined us all, we'd fill up the space of 135 Great Pyramids.
But even our biggest buildings are just tiny compared to what nature can do. Take Lake Baikal in Siberia. It is the largest freshwater lake on the planet by volume. To put that in perspective, it holds about 20% of all the world's fresh surface water in one single lake.
And even Lake Baikal is just a drop in the bucket. The total volume of all of Earth's oceans is so huge, you could fill the rings of Saturn 86 times over. Yeah, think about that. All that ice and rocks circling Saturn has less volume than just the water here on our own planet.
Okay, we've got a feel for our home. Now it's time to head out into our cosmic backyard, where our entire planet, it starts to look like a tiny little pebble. It's all about perspective. From down here, Earth feels enormous. You could fit 45 of our moons inside it, or about 170 dwarf planets like Pluto. But then you look at the real king of our solar system, Jupiter. Our world is just tiny. You could comfortably pack 1,400 Earths inside Jupiter. And as big as Jupiter is, it's nothing compared to the true monarch of our system, the Sun. The sheer volume of our star is just staggering. It is big enough to hold 1,000 planets the size of Jupiter. That's over 1 million Earths.
So think you've got a handle on things? Well, get ready for another jump. Because as massive as our sun is, on the galactic stage, it's just one of trillions. And a pretty average one at that. Let's go meet some of the real giants. This just shows you the pecking order out there. We start with our sun. Then we jump to a blue supergiant like Rigel. It could swallow 400,000 of our suns. Then you've got the red supergiant Betelgeuse, which could hold 600 million suns. But the current undisputed champion is Stephenson 2-18. It could hold 10 billion stars the size of our sun.
Okay, let's try to put that another way. Forget suns for a second. How many Earths could you fit inside the largest known star? 13 quadrillion. That's 13,000 trillion planets the size of our own. The number is so big it practically loses its meaning.
So we found it, right? The biggest thing out there has to be a star like Stephenson 2-18. It's a single massive object of unbelievable size. Well, no, not even close. The universe has monsters that make even the biggest stars look tiny.
Welcome to the realm of cosmic monsters. We are now dealing with things whose size and density justify easy explanation. We're talking about supermassive black holes and the very galaxies they live in.
Meet TON 618. It's an ultramassive black hole. This monster could swallow over 2 million of the biggest stars we know of. But even TON 618 gets dwarfed by the current record holder, Phoenix A star, which could swallow 4 black holes the size of TON 618. Okay, this is where we need to kind of shift our thinking. A black hole, no matter how huge, is still a single object. Now we have to start thinking about structures, things like nebula. These are enormous clouds of gas and dust where new stars are born, and they operate on a totally different scale. A monster black hole like Phoenix A star would be like a single grain of sand inside one of them.
And nebulae?
They're just tiny little components of something even bigger, galaxies. So the Large Magellanic Cloud is a dwarf galaxy that orbits our own, and it has billions of stars. But our Milky Way is so much larger by volume that it could swallow about 60 of them whole.
We've gone from pyramids to planets, from stars to galaxies. So now it's time for the final leg of our journey. We're about to do the final zoom out to see the largest structures that exist and really confront what the universe's volume is all about.
So here it is, the ultimate cosmic ladder. Our Milky Way is just one part of what's called the local group. The local group, in turn, is part of the Virgo supercluster, which could hold 7,000 local groups. But even that supercluster is dwarfed by cosmic voids, these massive, empty spaces between everything. The KBC void, for example, is so big it could contain 6,000 Virgo superclusters.
And this brings us to the most profound realization of this whole journey. After searching for the biggest thing, we've discovered that the greatest volume in the universe belongs to, well, nothing. All the stars, all the galaxies, all the cosmic structures we've talked about, all of it combined makes up so little of the universe's volume. It's just 1,000th of 1%. The universe, for all intents and purposes, is almost entirely empty space.
So how much empty space are we really talking about? Well, if you take that unimaginable KBC void, the one that could hold thousands of superclusters, our observable universe has enough volume to contain 17,000 of them.
And that right there is the ultimate takeaway. The answer to what's the biggest thing isn't an object at all. The real story of the universe's scale isn't about how big the things are, but about the truly incomprehensible vastness of the emptiness that separates them. Which leaves us with one final tantalizing thought to chew on. If everything we can see is just our observable universe and it's almost completely empty, what's beyond that? Could our entire cosmos just be one tiny bubble of something in an even bigger ocean of nothing? That's a question for another time.